Hey everyone, welcome to the session of ECA Electronic Circuit Analysis. In this class, we will learn about what is meant by Barkhausen criteria and how the oscillations generated by the circuit with Barkhausen criteria. So we will discuss about the conditions of Barkhausen criteria. So before going to know about the Barkhausen criteria, we should know that means what is an oscillator, what are the types of oscillators, and how the oscillations will be generated depending on the nature. So in previous class we already discussed all these topics. So before going to learn about this topic, let's revise the previous class ones. So first one, what is meant by oscillator? Already we know oscillator is an electronic circuit and it generates some AC signal. AC, that means without giving any AC input signal. So without giving any AC input signal, it generates some AC output signal and it uses some DC signal. That means we are applying some DC signal to the oscillator, and it, by the use of that DC energy, it can generate some AC oscillations, AC signal. Okay. So in order to generate the oscillations, here the oscillator uses some positive feedback. So normally we know the amplifier uses some negative feedback. That means in the feedback amplifier. So whereas in oscillator, it uses some positive feedback in order to generate the oscillations. So what is the difference between the amplifier and the oscillator? Because we know well about what is meant by amplifier. So amplifier means it amplifies the signal. That means it strengthens the weak signal. For the amplifier, we are giving some input signal in order to generate the AC signal or output signal. Here we are giving some AC input signal, and as well as we are applying some DC source also, DC signal also. So amplifier amplifies the input signal, AC signal. That means here we are applying some AC input. Whereas in the oscillator, we are not applying AC input, any AC input signal. Without giving any AC input signal, it can generate the output AC signal. Okay, that is the difference, main difference between the amplifier and the oscillator. Okay, and next, coming to the classification of oscillators, mainly we have two types of oscillations, oscillators. First one, sinusoidal oscillator. Second one, non-sinusoidal oscillator. So depending on the waveform generated at the output of the oscillator, we have two types of oscillators. So if we have some sinusoidal waveform at the output of the oscillator, then those type of oscillators are called as sinusoidal oscillators. And if we have some non-sinusoidal waveforms like triangular waveform, square waveform, or sawtooth waveform, so those type of waveforms are called as non-sinusoidal waveforms. And the oscillators which generate the non-sinusoidal waveforms is known as non-sinusoidal oscillator. And again, the sinusoidal oscillators are classified as four types depending on the components which we are using in the oscillator. And so here we have LC oscillators. So nothing but if you are using some inductor or the capacitor in the feedback network or in the circuit, then those type of oscillators are called as LC oscillators. Examples are Hartley, Colpitts, and Clark oscillator. And next, RC oscillator means it uses resistors and capacitors in the circuit. So example for the RC oscillators are RC phase shift oscillator and Wien bridge oscillator. So these type of oscillators uses some resistors and capacitors in their feedback network. And next one, crystal oscillator. Crystal oscillator means it uses some piezoelectric crystal in order to generate the signals. Next one, negative resistance oscillator means it uses some negative resistance characteristics. That means the oscillators uses some negative resistance characteristics like tunnel diode or tunnel devices. If tunnel devices are used by the oscillator, then those type of oscillators are called as negative resistance oscillators. So these are all the classification which represents the classification of oscillators. So next one, nature of oscillations. What is the nature of oscillations? We have two types of oscillations depending on the nature of sinusoidal wave. So first one, damped oscillations. Next one, undamped oscillations. So damped oscillations means the oscillations whose amplitude goes on decreasing. with respect to time. So that means like this. So these type of oscillations are called as damped oscillations. For these type of oscillators, we have some power loss, and there is no compensation methods if you want to require some compensation. Next one, undamped oscillations. Undamped oscillations means the oscillations whose amplitude remains constant throughout the time. So that means like this. So if you observe the waveform, the amplitude is constant at any time instant. Okay. So these oscillations in these type of oscillators, there is no power loss, and if any power loss occurs, then we can also apply some remedy or compensation techniques. Okay. And next one is positive feedback. So positive, normally oscillators uses positive feedback. So an amplifier with positive feedback produces the output to be in phase with the input. What is meant by positive feedback? Positive feedback means in the positive feedback network, we can have some output. That output is in phase with the input, and it also increases the signal strength. That means if you are using some positive feedback, then the output increases. Okay, or as well as the gain also increases. Obviously, it results some instability to the circuit, and this is the positive feedback, which represents that means this circuit represents a positive feedback. Positive feedback means here the output signal is in phase with the input signal, and here the input signal is represented as positive sign. Feedback signal is also represented as positive sign. So that means these two are is in phase, and we are combining these two signals. We are using some mixer in order to combine the input signal with the feedback network. Already we know feedback means we are applying some portion of the output to the input. Okay, so this is the positive feedback. By the use of positive feedback, the output increases as well as the gain also increases. So these are all topics we have covered in previous class. Okay. So next in this class, we will learn about the Barkhausen criteria. So what is meant by Barkhausen criteria? So we have mainly two conditions those two conditions are also called as Barkhausen criteria. So what are the conditions? So before going to know about those conditions, here we have some analysis. So normally the oscillator means it uses some positive feedback. Okay, that means it consists of some basic amplifier as well as some feedback network. So if you observe the figure, normally the oscillator consists of an amplifier, basic amplifier, and the feedback network. And here also we are using some positive feedback. So feedback amplifier means it uses some positive feedback or negative feedback. If you are applying some feedback, then those type of amplifiers are known as feedback amplifiers. Feedback means we are applying some portion of output to the input again. So, okay. So feedback amplifier consists of two parts. One is the basic amplifier, another one is the feedback circuit. Okay. And normally here the feedback circuit consists of resistors. Normally we are using some resistors in the feedback network. And next, the basic amplifier gain is represented as A, and the feedback network gain is represented as beta. This is the basic amplifier, and the gain of the basic amplifier is represented as A, and the feedback network gain is represented as beta. So consider the non-inverting amplifier with open loop gain. Let us consider an inverting amplifier with open loop gain. Inverting amplifier means, so here we have the inverting amplifier. Here we have the inverting amplifier. That means which inverts the input signal, which inverts the phase of the input signal. So let me explain here. Here we are applying some positive going signal, positive going sine wave. Okay, and whenever we are applying the positive going signal or positive going sine wave to the inverting amplifier, let us consider this is an inverting amplifier. Then the output of the inverting amplifier becomes like this. Okay, so that means the output waveform starts from negative side. Okay, that is negative going signal. So if the waveform is changed into this form, then we can say that the amplifier provides 180 degrees phase, because the phase difference between these two waveforms is 180 degrees. Okay, so here if you are taking some inverting amplifier, it inverts the input signal. That means we can have some negative going signal. That means there is the phase difference of 180 degrees between the input and output signal. The inverting amplifier provides 180 degrees phase shift whenever we are applying some input signal to the amplifier. Okay. And next, let us consider the feedback network, which is represented feedback network attenuation or gain, which is represented as beta, and that is less than unity. So here the basic amplifier, inverting amplifier produces 180 degrees phase shift between input and output. Okay. And next, so I am explaining the criteria. But before going to know about the criteria, we should know all the analysis. Okay. And finally, we can get the criteria. Okay. So here we are applying some input signal to the amplifier. That is also inverting amplifier. Here we can get some negative going signal. The phase difference between these two signals is 180 degrees. And next, so an input voltage Vi is applied to the amplifier and the output V0 value depends on the feedback network. So here we are applying some input signal. Let us consider an oscillator with the input signal Vi and the output signal V0. So the basic inverting amplifier will produce 180 degrees phase shift. We know that point. And we need a feedback network which provide a signal such that it must be in phase with the input of the amplifier. Okay. So let us consider the figure here. So this figure represents an oscillator. Okay. So mainly oscillator is a feedback network. That means it consists of two parts. One is amplifier, another one is feedback network. Okay. And the amplifier gain is represented as a feedback network gain is represented as beta. So here the inverting amplifier produces 180 degrees phase. That means here the positive going signal will be changed to the negative going signal when it passes through this amplifier. But our need in the oscillator is positive feedback, because our need is whenever we are applying the input signal, positive going signal, we should get the output as positive going signal only. That is meant by feedback, positive feedback. Okay. Positive feedback means the output is in phase with the input signal. There is no phase difference between the input and output whenever we are taking some positive feedback. Okay. So, but here, whenever we are using some inverting amplifier, it produces some 180 degrees phase shift. That means here we can get some phase difference. So, in order to get the same phase, that means in order to provide the same phase as the input signal, here we are applying some feedback network, and this feedback network provides another 180 degrees phase shift. That is called a positive feedback. Okay. That means in order to provide the positive feedback to the oscillator, here we are using some feedback network, and this feedback network provides remaining 180 degrees phase shift. Okay. So that means inverting amplifier provides 180 degrees phase shift and feedback network provides 180 degrees phase shift. That means here if this signal is applied to the feedback network, it provides the remaining 180 degrees. That is, it will be changed to like this. That means we can get some positive going signal. So if you observe the closed loop circuit, that means from inverting amplifier to the feedback network, again to the inverting amplifier, the total phase shift of the amplifier, or sorry, the total phase shift of the circuit or the oscillation becomes 360 degrees. Okay. So that means whenever we are using some oscillator circuit, it provides 360 degrees phase shift. That means 180 degrees phase shift is provided by the basic amplifier, and the feedback network provides the remaining phase, that is 180 degrees phase shift. And totally we can get the 360 degrees phase shift from input to the output. That is one of the criteria. That is one of the condition in the Barkhausen criteria. And next, so here we need some positive feedback. That means our feedback network provides the remaining 180 degrees phase shift. And let us consider an input signal or input voltage Vi is applied to the amplifier, and the output voltage will be V0 is equal to A into Vi. So here we are applying some input voltage. We are applying some input voltage. This is the imaginary input, because already we know oscillator definition is without giving any AC input signal, we are getting some AC output signal. So this is the imagine, because here because of some DC voltage, how we can get this input voltage at the first condition? Here we are not applying any input. Just consider we are having some input signal here. At the input of the inverting amplifier, we have some input voltage. So that input voltage generated internally in the circuit because of the DC voltage which we are applying to the oscillator or to the circuit. Okay, we are applying some 12 volts or 15 volts constant voltage. That is also called as DC voltage. Because of that DC voltage, we can have some internal voltage. Internal voltage at the input of the inverting amplifier. That is represented as VI here. We are not applying any input externally to this circuit. Okay. So here VI is the input voltage. Okay. And V0 is the output voltage for the amplifier. So what is the output voltage if you are applying some VI? We know the gain of the amplifier. The gain of the amplifier is represented as A, and that is represented as the ratio of output voltage to the input voltage. So that is A is equal to V0 by VI. A is equal to V0 by VI. From that equation, what is V0? V0 is equal to A into VI. This is the output voltage of the amplifier. And the feedback network attenuation factor, that is the feedback network gain, beta, is represented as. So what is beta? What is beta? Beta is the feedback network gain. And mathematically, we can also say that the output voltage of feedback network, the ratio of output voltage of feedback network to the input voltage of feedback network. Okay, beta is the ratio of output of feedback network to the input of feedback network. So here let us consider the output of feedback network is VF. The output of feedback network is VF, and the input of feedback network is V0. V0 is the output of the inverting amplifier. That is again fed back to the input by the use of feedback network. So the input for the feedback network is the output of the inverting amplifier, that is V0. Okay. So for the feedback network, V0 is the input voltage and VF is the output voltage. And what is beta? Beta is equal to output VF by input V0. So beta is equal to VF by V0. And from that equation, what is VF? If beta is VF by V0, VF becomes beta into V0. So this is the feedback voltage. Okay. So by substituting the above equation in this case, already we know VF is equal to beta into V0 and V0 is A into VI. So let's substitute the value, and VF is equal to beta into A into VI. Okay. And we know that for the oscillator, there will be no additional input signal. That means for the oscillator, we are not applying any external input signal. That is, the feedback signal VF must act as the input for the amplifier. So here we are not applying any external input signal. Whatever the signal from the feedback network, that signal will act as the input signal for the inverting amplifier. So what is the input for the inverting amplifier? That is the output of the feedback network. That is, VF is the input of the inverting amplifier. And mathematically, we can also say like this. So, that is, VF is equal to VI. What is the input voltage? Input voltage is the output of feedback network voltage. Okay. So that is VF is equal to VI. So if VF is equal to VI, then what is A beta? If feedback network voltage, output of the feedback network voltage is equal to the input voltage of the basic amplifier, then VF equal to VI, then A beta becomes 1. Okay, that is magnitude of A beta is equal to 1, where A is the basic amplifier gain, beta is the feedback network gain. So from this equation, we can say that magnitude of the product of basic amplifier gain and feedback network gain is equal to 1. Okay, this is one more condition of Barkhausen criteria. Okay, so here A beta can also be called as loop gain. The other name for A beta, that is the product of A and beta, is loop gain. The magnitude of loop gain must be unity. This is one of the condition of Barkhausen criteria. So as we discussed above, the feedback network will produce 180 degrees phase shift, and the inverting amplifier produces 180 degrees phase shift, and the total circuit or the total loop will be 360 degrees phase shift. That means for the circuit, for the oscillator circuit, it produces 360 degrees phase shift. As well as for the oscillator circuit, what is A beta? The product of A and beta must be equal to 1. So for any oscillator, in order to generate some oscillations, that circuit must satisfy these two conditions, and these two conditions are called as Barkhausen criteria. Okay, so these two conditions are called as Barkhausen criteria. So any circuit work as an oscillator, it should satisfy these two conditions. First condition is the total phase shift of the circuit or the total phase shift of the closed loop must be equal to 360 degrees. That means from input to the output, again to the input, it provides some 360 degrees phase shift. That is, the amplifier provides 180 if we are taking some inverting amplifier. If it produces 180 degrees phase shift, the remaining 180 degrees phase shift will be provided by the feedback network, because in the amplifier, in the oscillator, it uses some positive feedback. That means input and output must be, input signal and output signal must be in phase. So in order to get the oscillations, the circuit must satisfy this condition as well as second condition. Second condition is the product of magnitude of amplifier open loop gain and the magnitude of feedback network gain beta must be unity. That is, mod A beta must be unity, that is equal to 1. A beta can also be called as loop gain. Okay, so these two conditions are called as Barkhausen criteria. First one, total phase shift of the closed loop must be 360 degrees, and second one, magnitude of the loop gain must be unity. So in order to analyze the oscillators, we should remember these two conditions, and these two conditions are also called as Barkhausen criteria. So this is the analysis of the oscillator. Thank you.